Hello, welcome to chemistry class. Today we are going to discuss one of the most important topic, that is states of matter. Okay, states of matter. In that states of matter, we are going to discuss the important topic is molecular velocities. Okay, the molecular velocities we are discussing. Okay, molecular velocities are so many types is there. In that, root mean square velocity is the first one. Molecular velocities, in that the first one is root mean square velocity. Okay, so in that molecular velocities, the first one is most probable velocity. The next one is average velocity. The next one is root mean square velocity. This is the three types of velocities: most probable velocity, average velocity, root mean square velocity. Okay, let us go to the discussing of first one. Okay, the first one is most probable velocity. Before going to discussing of most probable velocity, we are going to discuss root mean square velocity. Root mean square velocity is also called as RMS velocity. What we are calling root mean square velocity is also called as RMS velocity. What is the root mean square velocity? Now we are going to discuss. Root mean square velocity is also called as root mean square speed. Is so many types of representation. One is called the so many types is there to representation, that is CRMS, or URMS. This is the two ways we can represent the root mean square velocity. What is the definition of root mean square velocity? This is the definitions here. Here V1, V2, V3 are the velocity of different molecules. Okay, suppose in this here there is a three gases are present. One is called as, this is the first gas, this is the second gas, this is the third gas. First gas, second gas, third gas. There is a three gases are present. Their velocity is equals to V1, V2, V3. That is their velocities. Okay, then the total kinetic energy of these molecules, suppose in this one gas there is a n number of molecules, is the two gas also containing n number of molecules, three gas also containing n number of molecules. The three gas molecules, the three different gas molecules having some kinetic energy. It's having some kinetic energy. The first these first gas is having some kinetic energy. Second gas also having some kinetic energy. Third gas also having some kinetic energy. Okay na? So is the sum of these kinetic energy of the molecule of induced molecule, the total kinetic is equals to what? Suppose kinetic energy is total kinetic energy is equals to sum of the kinetic energy of one plus kinetic energy of second gas plus kinetic energy of third gas. Okay, the sum of the kinetic energy of three gases is equals to kinetic energy of first gas, kinetic energy of second gas, and kinetic energy of third gas, and so on and so on. Okay na. So let us go to the what the detailed study of this one now. Okay na. So when you go for this one, their RMS velocity is equals to root mean square velocity is equals to what? We have nv square, that is equals to nv square, that is equals to v1 square plus v2 square plus v3 square. Okay na. After the definition, the total kinetic, what is the statement of RMS velocity? The total, this is a statement of RMS velocity. What is the statement here? If v1 and v2 v3 are the velocity of different molecules, then the total kinetic energy of the n molecules is the sum of the kinetic energy of the all molecules. Now based on the definition, we are going the v1, the total velocity v square is nothing but what? Total velocity of the gas molecules into what? Number of gas molecules, that is called as n, is equals to what? v1 square plus v2 square plus v3 square and so on. Now suppose if I take the what? v2 square, then it is become v1 square plus v2 square plus v3 square and so on, divided by, if I take this n into this side, then divided by n, divided by n. Okay na. Now suppose if I take the v, if I want to remove the square here, then v is equals to what? Square root of v1 square plus v2 square plus v3 square and so on, divided by n, divided by n. Okay, this is a root mean square velocity. This is also write by either vrms, we can also write the vrms, and we can also write the urms, and we can also write the crms. Anything we can use, either vrms we can use, or crms, urms we can use, or crms we can use. And when you go for the problem solving, you should be go with following formulas. What is the formulas which are there for the problem solving? Okay, a root mean square velocity is also given by the following expression. That expression is urms is equals to square root of 3 RT divided by 3 RT divided by m, 3 RT divided by m. This is also the formula of urms. Okay, urms is also calculated by square root of 3 RT divided by m. Here we know that PV is equals to what? PV is equals to nRT. PV is equals to what? nRT. For 1 mole of gas, PV is equals to what? Sorry. Okay. PV is equals to RT. PV is equals to RT. Okay, that's why in the place of RT, we are substituting the what? PV. Okay na. In the place of RT, here RT is there, no? In the place of this RT, we are substituting the what? PV. We are substituting the what? PV. Then we know that here the thing is very important here is in this one, root 3 PV divided by m is there, no? In that PV root 3 PV divided by M is there, no? In that V and M, value by M is equals to what? Density. Value by M is equals to what? Mass by volume is equals to density. Mass by volume is equals to what? Density. Then value by M is equals to 1 by density. That's why in the place of volume by M, in the place of volume by M, we are substituting the is 1 by D. Then it is become root 3p by d. Why we are writing root 3p by d? Because in the place of value by m, we are substituting the 1 by d. We are substituting the what? 1 by d. Okay, na? So that's why here in the place of value by m, we are substituting the what? 1 by d. Then we will get the root. Then we will get the root 3p divided by d. Okay, this is the three formulas are very important to solve the which one? Root mean square velocity. Okay, na? So here is another very important thing is URMS is calculated by three formulas. One is square root of 3RT by M. Okay, na? So this is a formula, square root of 3RT by M. You know that PV is equals to what? RT. That's why in the place of PV we are substituting, in the place of RT we are substituting the what? PV. Then here value by M is equals to what? 1 by D. Value by M is equals to what? 1 by D. That's why we'll get the final expression is like this. Okay. Next very important topic is, here is the next topic. The next topic is URMS calculation only. URMS only. When you go for URMS only, but the URMS calculation in different conditions. The first URMS in different conditions. The condition number one is for gas two different temperatures. Okay, na? For a gas two different temperatures is nothing but this is the same gas. Suppose what is the URMS basic expression? The basic expression is, this is the first expression, 3RT divided by M. 3RT divided by M. This is the first expression, right? Here R is equals to gas constant, T is equal to temperature, M is equals to what? Molecular mass. Here one is, there is a particular gas, but the temperature is different. Temperature is different. In that situation, we are using the formula is following this formula we are using, that is URMS 1 divided by URMS 2 is equals to, here 3 is a constant, R is a constant, M is a constant. Why? Because 3 is a numerical value which are constant, R is always gas constant, M is the what? Only one gas. Same gas, the temperatures are different. Then it is become square root of T1 divided by T2. That is the first condition. Okay. The second condition is the first condition. The second condition is there is a two gases. Okay, there is a two gases, but the temperatures are different. There's a two gases are having the same RMS velocity. Okay, na? Both having same RMS velocity. Two gases having same URMS. Then which is a constant? URMS is a what? Constant. URMS, this is a what? Constant. When this is a constant, when the two gases, see, this is a basic expression, this is a basic expression. URMS is a constant, then what is a constant here? 3 also constant, R also constant. But I am not saying that temperature is a constant, and also I am not saying that two gases, no, when the two gases M also what? See, if I take once again here, you get the clarity now. Once again I will take, let us see that URMS is equals to root 3 RT, sorry, root 3 RT divided by M, root 3 RT divided by M. Okay, here what is the constant here? Two gases having same URMS means this is a constant. This is a constant. And also which is a constant? And also which is a constant here? Root for same. 3 also constant, R also constant. But what is the difference here? Temperature is different, mass is different. When temperature is different and mass is different, then we get the expression is okay, square root of T1 divided by M1, square root of T1 divided by M1, that is equals to square root of T2 divided by M2. Okay na? Okay na? So okay, now here we can cancel the both this, we can cancel the square roots. Then T1 divided by M1 is equals to T2 divided by M, T2 divided by, sorry, T2 divided by, of course is right, M2. Okay, now this is the third condition. What is the third condition here? The third condition is two gases having same URMS but different temperature, different molecular mass. In that time we have this formula. The next condition is, but this is also next condition is two gases. This is a two gas. This is the third condition. The third condition is two gases is nothing but molecular mass is different. M2 is different. Two gases M1 and M2 is different. Okay, two gases here means M1 and M2 is different. Same temperature. Here is a what? Same temperature. Same temperature. In that situation, two gases having same temperature, in that gas we have this expression. Means here URMS is not same. Then URMS1 divided by URMS2, that is equals to two gases having same temperature means what is remaining here? The remaining is, see, you know what is the basic expression? What is the basic expression? URMS is equals to square root of 3 odd T divided by M. Which is a constant here? Two gases having same temperature means 3 is a constant, R is a constant, and T is a constant. Then what is remaining? The remaining is M. Then square root of M2 divided by M1. Square root of M2 divided by EM1. Okay na? So Then last condition is there's a two gases. Last condition is there's a two gases. Fourth condition is there is a two gases, different temperature. This is the last condition. Different gases and different temperature. Different gases, different gases, different temperature. Temperature means gas is also different, temperature is also different. Then we have final expression that is called as URMS 1 divided by URMS 2, that is equals to URMS 1 divided by URMS 2, that is equals to square root of T1 divided by T2 into M2 divided by M1. Okay, these are the different formulas which are used to calculate the RMS velocity. Okay, now the next topic is we'll discuss one MCQ here. The MCQ is, so this is MCQs. Formula for root mean square velocity is A option, URMS is equals to what? So these are the options are given to you. This is once again a clarity I will write here. The C option is you see they already mentioned that either CRMS we can write or URMS we can write, there is no problem. URMS is equals to square root of 3p divided by d. Which option is correct among this? All of this option is correct. Next one is average velocity and most probable velocity. This is the two velocity we have, average velocity and most probable velocity. Let us go to discussing of average velocity. The average velocity is represented by so many ways. In that is U average or C bar. Average velocity is represented by two ways. One is called as U velocity, U average, or C bar. Another way to represent the average velocity. What is meaning of average velocity? It is the average velocity of different molecules of the gas at any instant at given temperature. Means in particular instant of time you have to take their average speed of all the molecules we have to calculate. For that we have following formulas is there. Suppose imagine v1, v2, v3 is the velocity of different molecules which are present in the what? Okay, now one molecule. Then u average is equals to v1 plus v2 plus v3, then divided by n. Why? Because there is a presence of what? N number of molecules. Now this is a formula to calculate the average Average speed of velocity u average is equals to what? 8 square root of 8 rt divided by pi m, that is also is equals to square root of 8 pv. Why? Because pv is equals to what? Rt. When pv is equals to what? Rt, in the place of pv we can also substitute the what? In the place of Rt we can also substitute the what? Pv is equals to pi in that is all u average is equals to what? Square root of 8 pv by pi m. Then final expression is, we can also write, already I mentioned that volume by m is equals to what? 1 by d. Then you will get the root 8p divided by d. Okay, then is a very important, the relation between the u average velocity and rms velocity is u average velocity, which is equals to 0.9214 into u rms velocity. Okay na? So when you multiply with u rms velocity with 0.9214, then it is become to the what? U average velocity. Okay, the next one is, suppose if you take the urms velocity, then urms velocity is equals to urms velocity is equals to 1, if you multiply with u average velocity with 1.085, then which is equals to what? U rms velocity. These expressions are important. The next one is most probable velocity. Most probable velocity, what is the definition of most probable velocity? Is the speed which are possessed by the maximum fraction of molecules, okay na, when it is given temperature, is called as most probable speed. Means if you take some gas molecules in this beaker, if you take some gas molecules, in that there is so many gas molecules are present, in that the velocity with, or the speed which are possessed by the maximum fraction of molecule. Okay now, so so many molecules are present here, in that maximum number of molecules are possessed by which speed, that speed is called as most probable velocity. These are represented by u mpv. Is also, we have another way to represent the what? Most probable velocity, that is called as cp. Cp is nothing but what? Most probable velocity. We have following formula to calculate the u mpv, most probable velocity, or cp, that is equals to what? Cp is equals to what? Square root of 2 rt by m, and in the place of rt you can substitute the what? Pv. Then square root of 2p divided by m, then, and volume by m is equals to 1d, then you can write the what? Square root of 2p divided by d. And it's a very important thing you have to go now. Here m is called as molecular mass of the gas. Then when you come to the comparison between these three, u most probable velocity is equals to what? Square root of 3 pv divided by m, no, then that is equal that into what? U rms. Or we can also write like this expression, uh, u most probable mpv is equals to 0.8166 into u rms. Okay, when you compare between the root mean square velocity and most probable velocity, the most probable velocity, which is equals to 0.8166 into root mean square velocity. Next is, suppose if you take the urms, when you take the urms, urms is equals to what? 1.224 into u most probable velocities. U most probable velocities. Okay. Next is relation between the different type of velocities. Three velocities we are going to discuss in the relations. The one is different of velocity, different types of velocity is nothing but square root means square velocity, RMS velocity, and is nothing but root means square velocity is nothing but RMS velocity, and another one is called as average velocity, and another one is the most probable velocity. We have to relate the each other. When you go to the relating of each other, okay na, this is the expression you will get, that is u most probable velocity is nothing but u most probable velocity ratio u is to u average average velocity into u RMS velocity is equals to 1 is to 1.128 is to 1.224. Suppose we can also write like this, that is u RMS velocity and u average velocity and u most probable velocity is 1 is to 0.9213 and 0.816. This is a very important for competitive exams. They will ask a direct question from this, and also we can write like this, this is a this is also we can write, that is see you see, you know that I may already mentioned to you, CP is nothing but what, most probable velocity, most probable, that is called as u most probable velocity, and another one is what, mu u average velocity, it is to u average velocity into u most probable velocity, which is equals to root 2 is to root 2.55 is to 2.55 is to root 3. This is also another expression we can write. This is the three relations between the 1 by 1. Okay, okay, or we can also write like this, root 2 is to, okay, root 8 by pi is to root 3. Like this also we can possible to write between the all relations. This is a very important topic. So finally if we come to the comparison, which is most which is highest velocity, the highest velocity is CRMS velocity is the highest. CRMS velocity is the what, high. Which is the lowest velocity? The lowest velocity is the what, most probable velocity is the what, lowest. When you come to the order, okay na, when you come to the order, CP is very less. CP is nothing but what, u most probable velocity is less when compared to what, C average, very high is CRMS. Okay nama, in the place of C we can also write the what, u. In the place of this C also we can write the what, u. In the place of this C also we can write the what, u. Okay, this is a very important topic for the competitive exams. In the next section we are going to discussing problems and different MCQs on this topic. Okay, thank you so much. Please subscribe my channel so you can get the more updates. Thank you so much.